In this session, we're going to be looking at the difference between RISC and CISC based processor architectures. So far we have looked at what the processor is, and we've looked at this idea of instruction sets, where each processor will have a set of instructions which it can run. Now, the reality of the situation is that if every single processor produced has different instruction sets, then software would have to be compiled and produced to match just that individual processor, which is very inefficient. So what actually happens is there's instruction sets which kind of stay the same for different processors. Okay, so we're going to look at the two main types and where they're used and the advantages and disadvantages of both. I've just kind of talked about that. Instruction sets. So each processor has set instructions. Now, we've looked at this already, so I'm going to quickly this is more revision than anything else. Each instruction has a unique opcode. So if you remember, a machine code instruction is made up of two parts: the opcode, the command parts, the thing that it's going to do, and the operand, the data it's going to be applied to. And each opcode has a unique binary value. So when we have an instruction set, every single instruction in that set will have a separate binary value or opcode to represent it. Now, there's two main processor architectures out there in common use. The first one is the x86 style, so that's either 32-bit, 64-bit, and that's the kind of architecture you find in normal desktop PCs, laptops, and things like that. So it tends to be Windows-based Windows-based computers, or Mac as well is using x86. And then you've got ARM. Now, ARM is a competing architecture that is it tends to be found on mobile devices, so mobile phones, iPads, tablet devices, and things like that. So specifically, the x86 is known as a CISC-based architecture or complex instruction set, whilst ARM is a RISC-based architecture, reduced instruction set. So we're going to look at the difference between the two. Now, in terms of the exam, you don't need to know that ARM is RISC and x86 is CISC, but it's good to know an example of them. So when you do your extended reading on this subject, you can actually have a little bit of context to put that in. So let's start looking at RISC. Now, RISC architectures use a very small number of simple instructions. So rather than having a really large set of instructions, it will use a smaller set and then use those instructions to complete any task that you need to do. Okay, so we'll have enough instructions to do all the tasks that a computer needs to do, but not have loads of extra ones to do other extended things. So each instruction can be completed in a single clock cycle. Every single instruction always takes one clock cycle to complete, and that's kind of what we're used to already. Single instructions are going to run much faster, but as a big trade-off, I might need quite a lot of instructions to perform even the simplest of tasks. We are going to look in later lessons at a very specific example of a RISC style architecture, which is Little Man Computer, where there's only 10 instructions and there's a lot of things you can do with just those 10 instructions. But the real RISC architecture out there is ARM. CISC, on the other hand, use a large number of complex instructions. Okay, so the structure, there's a much higher amounts of instructions. The instructions can be quite specific and only used in certain circumstances. They're going to be much complex, and because of the complexity of some of these instructions, they might actually take more than one clock cycle to complete, so 2-3 clock cycles. However, because these instructions are more complex, I might only need one instruction to complete a task, whereas RISC might need a number of instructions to complete the same task. Okay, desktop computers, laptop PCs will use CISC. Now, I'm just going to pause for a moment just to be really clear about the difference between an instruction and task, because some students kind of get mixed up with that idea. So when I'm talking about a task, I'm talking about something that you want to do on the computer. So that might be, I don't know, calculating the sum of something, or it might be displaying a 3D object on screen. This is something you want to accomplish with the computer. Instructions are actually machine code instructions. Okay, so these are the instructions CPU is going to run, and in order to do any given task, I'm going to need one or more instructions to do so. Okay, so think of it this way: when you're programming to solve a problem, so I don't know, calculating the average of a set of numbers, you can need a number of lines of code. Okay, so each line of code would be the equivalent of an instruction in this scenario, and the task would be the thing you're trying to achieve. In this case, calculate the average. Okay, so that's the kind of the difference between the two. Okay, so in process terms, a task will be something that you're trying to program the CPU to do. Instruction is going to be one opcode that's going to get run. So it's worth kind of having comparisons. So there's not a huge amount you need to know for RISC and CISC apart from what they are and what's different about them. So RISC has a small number of instructions, of simple instructions. CISC has a large number. So you can see there's a very simple thing. So also notice it's simple and complex. Okay, so it's almost a polar opposite of each other. I'll come back to addressing modes in a moment. So may require multiple instructions to complete a single task. Can use single instructions to perform tasks. Okay, so the clarification here is that RISC will almost certainly always use lots and lots of instructions to complete any given task, while CISC, there are specialized instructions in the hardware which actually will complete tasks which, if it didn't RISC, would probably need lots of instructions. Instructions always take one clock cycle in RISC. However, due to complexity in CISC, they might need more than one in CISC. Now, just going to come back to addressing modes. Now, we've not really talked about addressing modes in any great detail. So, few addressing modes, large number of addressing modes. The key difference here is few and large. Okay, we're going to talk about addressing modes in detail in A2. Okay, so I'm just going to very briefly, as a kind of thing in the air kind of explanation. We know what a memory address is. Okay, it's the location of where we find data. Now, addressing modes is the way we go to access that data. Okay, is that data going to be part of the instruction, or is it going to have an address where I'll find the data? Is it going to be using an array or something like that? So there's different addressing modes that can be used. CISC obviously has a lot more of them, like different types and styles, which are used only in certain circumstances. RISC, on the other hand, has a few ones which kind of a catch-all, which will do everything you need to do. But again, I might need more instructions to do something that maybe could be done in one instruction in CISC. So time to pause and get some notes on this. So make notes on the RISC and CISC. It's really important to understand what they are and the differences between the two. The last thing we need to know about is the advantages and disadvantages of RISC and CISC. Now, the one thing you'll find when you're researching this online is that a lot of the pages written about RISC and CISC are not designed for A-level students. They are really aimed at students at undergraduate level who have maybe some knowledge of microprocessor design. They're not very accessible. Okay, so what I've done is I've kind of picked up on the main advantages. So I'm going to try and explain them in a bit of detail. And I've got some links for further research to help you with this. So, simple hardware design. Now, there's a big focus for RISC on the hardware, rather on the software. So the software is going to be doing most of the heavy lifting, whilst in CISC it's the hardware doing the heavy lifting. So because I've got a few instructions, because the software is doing most of the hard work, the hardware becomes simpler to design. Okay, so it requires fewer transistors, and all that kind of stuff. RISC processors tend to be able to run faster than CISC because of the simplicity of the hardware, we can achieve higher clock speeds, and they tend to run, based on the research I've done, 2 to 4 times faster than CISC. Okay, so they are faster due to the simple hardware design. And as I said before, less emphasis on the hardware. So we're not using the hardware to do a lot of the heavy lifting. We're actually getting the code, the software, to do the same thing. For CISC, because we have the hardware doing a lot of the heavy lifting, it is going to be more complicated hardware. However, it means I can have specific instructions which are optimized for certain operations. Okay, so most processors will have optimizations. Certainly the Core i7s and all that sort of stuff will have certain instructions which are only used in certain circumstances. For example, there's going to be some instructions which are just for floating point calculations, and they're there to kind of speed up those operations. There's some for 3D graphics, and there's loads of very specific optimized instructions which can be used in certain circumstances to speed things up. They are situational, so just because these optimized instructions are there doesn't necessarily mean that it's always going to be faster. However, for certain operations and certain programs using certain approaches, it is obviously going to help and speed things up. Because we use few instructions to complete a task. Now remember, with RISC, I need quite a lot of instructions to do a single task. With CISC, because I need few instructions, I need fewer fetches. Now remember, a fetch from memory is a slow operation because I'm having to access something from memory, which can be up to 16 times slower than the CPU. So there's less chance of delay due to accessing slow RAM. Now remember, it's okay if I'm hitting the cache, it's not a massive delay for me in cache, but what if I'm not hitting cache, okay? So there's that chance for delay every time I do a fetch. Because I'm using few instructions in CISC architectures, there's going to be less delay just by default because I'm accessing fewer of those instructions. Compiler design can be simpler because I don't have to use as many instructions, and the instructions themselves are designed to better match high-level languages. So high-level languages, what I'm really meaning by that is the coding that you do in your lab sessions, so like Python, C, and all that sort of stuff. So some of the commands that we use in those can be kind of mapped a bit closer to instructions that in the CISC-based architecture, and because of that, compiler design can be simplified. So it's important to get a list of advantages and disadvantages. Now, there's not a huge amount for either architecture, so it's probably worth doing a little bit further research just to make sure you understand them, because they're quite technical reasons. So it's worth doing a bit of background reading. So I've included 2 links. One kind of gives you an overview of RISC and CISC. The other will give you an overview, but B, a bit more detail about the advantages and disadvantages. So I would strongly suggest you read over both of them before actually going off and making a list of advantages and disadvantages. Subject clarification. What you need to know for the exam is candidates need to understand the differences between RISC and CISC. Okay, so I've already shown you that slide with differences. That's crucial, you have that in your notes. And the key features and benefits of each. Okay, and then candidates should be aware of the relative benefits of each architecture. So I'm not sure why they've said benefits twice, because I can't think they're saying the same thing twice. But ultimately, you do need to know why might we use RISC and CISC over the other ones, and that could well be a classic 9 marker, as well as a standard what are the advantages and disadvantages of it.